will be seeing a case study on heat equation depending on a rod. A rod is being taken which is 30 centimeter long, and we are having two degrees, that is A and B, which is 20 with respect to A is equal to 20 and B will be 80 degree. On the heat equation depending, which is dou U is divided by dou T, that is equal to.
So what they are telling is, this is the heat equation. In this heat equation, at steady state condition, I told you already, we know that in a steady state situation, listen, the steady state situation, your heat equation can be written as U of x equal to Ax plus b. Okay, in a steady state condition, your heat equation can be resolved as U of x equal to Ax plus b. Listen here. So this is the rod, this is the edges, A point and B point, end points. So you are giving 20 degrees Celsius here, you are giving 80 degrees Celsius here. So after steady state condition, the temperature, you stop heating it so that it goes down, it is reduced to 0 degree. So okay. So initial stage. So in initial stage, what was the temperature at A? A is 20, B is 80 degree. Okay. Now you take this concept. In this concept, at the point x equal to 0, in this corner, here x equal to 0, what is the temperature? 20. So you take at x equal to 0. At x equal to 0, what is U of x? U of x is nothing but heat. So when x equal to 0, what is your temperature? 20 degree. So in the place of U of x, you will substitute 20. So this is, so when you put x equal to 0, here also 0. So this term becomes 0. So you will get b equal to, what is U of x? It is 20. So b is equal to 20. So this work is over, you got b equal to 20. Now you come here, b is the other end point. So here, actually from here to here is 30 degree, 30 centimeter. So x is 30 here, right? X is 30. So at the point of 30 centimeter, what is the temperature? 80. So at x equal to 30, your U of x is 80. So you substitute in this formula. So A into 30 plus B, which is equal to 80. So already you know what is the value of B. You substitute B is 20. So from this when you solve, you get A equal to 2. Now you know the value of A and B. What is A? A is 2. What is B? B is 20. So you can substitute in the formula, in the B. That is in this expansion. U of x equal to Ax plus B. Now U of x is equal to, what is that? You are going to substitute U, that is A as 2 and B as 20. You get U of x equal to 2x plus 20. Am I right? 2x plus 20. So your U of x is equal to 2x plus 20. Got it? Then you know very well, like your wave equation, heat equation also has certain conditions. So what are the conditions? These are the conditions. So U of 0, t equal to 0. U of 30, comma t is equal to 0. That because after steady state condition, you are reducing the heat to 0 degrees Celsius. So at that time you start the experiment. So in this point, so the temperature at U of, that is 0, t, it is 0. After steady state condition, it is stop heating it. Here also. So this 30, t is the temperature at peak point. So here also it is 0. Now, what is the function we arrived? So U of x, 0 is the function arrived. That is 2x plus 20. So here instead of f of x, that is nothing but 2x plus 20. Now you have three conditions. This is what you are going to use for the solving process. So you know already for wave equation we have a suitable solution. Similarly for heat equation also we have a suitable solution. U of x, t is equal to a into cos px, b into sin px, e power minus alpha square, p square into t. P square into t. So this is the very important suitable solution for heat equation. So you should have in your mind. So here this is where you are going to apply each and every condition. When you apply the first condition, what is that? When x equal to 0, your distribution is 0. You apply here. When x equal to 0, wherever you have x, you have to substitute 0. So its answer is 0. So you substitute condition 1. That is, if I apply this condition in this equation, that is what is here. So when you apply x as 0, you get this around because the cos 0 is 1, sin of 0 is 0. So this can be eliminated. You have 1 here. So a into e power alpha minus alpha square p square t. That is what you get. So in these two, you have to have in mind always this e power term cannot be equal to 0. So only possibility is a equal to 0. So from the first condition, what we understood, a value is equal to 0. So again, after finding the value, where you substitute? Again, you have to substitute in the suitable solution. So this term vanishes. So you have this amount. That is what is here. So after pasting a equal to 0 in equation 1, you will get this result. So what you do? You substitute the second equation, second condition. So when you apply the second condition, similar to how we saw in wave equation, what we get lambda equal to n pi by l. Second condition, when you apply, you get lambda equal to n pi by l. Here l is 30 because in this problem we know l is 30 centimeters. So l becomes 30. Same answer. There is n pi by l. Here n pi by 30. So you substitute the equation. Second work is over. What is the third one? You have to apply the function. So that is what is happening here. So after applying, there we have lambda. Here it is p, a small term difference. That's all. So when you apply, you get this result. In this result, after, so what is the third condition? When t is equal to 0, this is the function. Am I right? So what is t? T is 0. When you substitute t equal to 0, the value of t here. What is e power minus 0? E power minus 0 is
1.
E power 0 or whatever. What is it?
1.
1. So this term vanishes. You have this one here. So this constant term can be written as summation. So how will you find the Bn value? By using half range Fourier sine series. Alright, when you substitute half range Fourier sine series, you will get the B value, which when you substitute in the final expression, that is in u of x comma t, you will get the answer. Got it?